All right, today we're going to do 11.2a, which is more methods for evaluating limits. The first one we've already done, direct substitution, and technology we've already done. We've already used a graph and table to find limits or if limits exist. But we're going to go over dividing out and rationalizing and look at direct substitution again and using technology again. So dividing out is when evaluating rational expression when we have to factor and cancel out common factors. So that's like we've done in the past where we've factored the top and the numerator and the denominator and then canceled out. Okay, after we do that, then we use substitution. Rationalizing, anytime we're working with limits, we rationalize the numerator by multiplying the top and the bottom by the conjugate. Okay, so we're going to do an example of that also so you can see what that looks like. Okay, so let's actually take a look at what some of these look like. So the first one is just going to be direct substitution. So I'm going to take this -1 and plug it in. So I'm going to have -1 squared plus -1 minus 6. So that's going to be 1 plus -1 minus 6. So my answer, my limit, as x approaches -1 is going to be -6. Let's go on ahead and try this second one. So we already know that the numerator is -6 because it's the same one as we had up there. Let's go on ahead and we just did that by plugging that -1 in. So -1 squared minus 1 minus 6. Okay. All right, so let's go on ahead and plug this in here. So -1 plus 3 is going to be 2. So our answer then is -3. Let's take a look at this third one. So our limit as x approaches -3. Well, if I plug a -3 in here, then I get -3 plus 3 equals 0, and I can't do that. So I need to actually use our dividing out rule or factoring. So x squared plus x minus 6 factors to x plus 3 times x minus 2. And then I'm left with x plus 3 in the denominator. I'm going to cancel those out. Remember when I cancel, that really becomes a 1. Okay, so then I'm going to be left with x minus 2. Now I can plug that -3 in. So -3 minus 2. And that's going to give me a -5. Okay, so that's our dividing out rule. Okay, if you get a 0 in the denominator, then you're going to have to use that dividing out rule. Let's take a look at the next one. So the next one is also going to be dividing out. So here I have 4 terms, so I'm going to be able to factor those. So I can factor an x squared out, and I'm left with x minus 1. Here I can factor a 1 out, and I'm left with x minus 1. Okay, so my factors then are x squared plus 1 times x minus 1. Okay, so now I'm just going to go on ahead and rewrite this. So my numerator was x minus 1 over my x squared plus 1 times my x minus 1. Now I'm going to cancel out what I can. And remember, once again, when I cancel, it's really dividing a number by itself, which gives us a 1. Okay, do not put a 0 up there. You will make huge mistakes by doing that. Any number divided by itself is 1. Okay, and then we're left with x squared plus 1 in the denominator. So now I'm going to go on ahead and I'm going to plug that 1 in. Okay, direct substitution. So 1 over 1 squared plus 1 is just going to be 1 over 2, which is 1/2. Okay, let's look at rationalizing. So in the numerator here, I have a radical minus a 1, so I need to multiply by that conjugate. So that's going to be the square root of x plus 1 plus 1. And anything I do to the top, I have to do to the bottom. So the square root of x plus 1 plus 1. All right, so I'm going to just go on ahead and do this. So that's going to be the square root of x plus 1 squared because it's times itself. And then I'm going to do the square root of x1 times +1, which is plus the square root of x plus 1. And remember, anytime we rationalize denominators, we always get rid of one term. Okay, so now I'm going to do minus square root of x plus 1. So those are going to wind up canceling. And then I have -1 times +1, which is just a -1. Okay, my denominator, I'm just going to leave it as x times the square root of x plus 1 right now. Okay. All right, I'm going to go on ahead and do this. So I'm going to get the square root of x plus 1 squared, which gives me x plus 1, and then I have that minus 1. Okay, that's going to go away and equal 0. And then in the denominator, I have x times the square root of x plus 1 plus 1. Well, those x's can cancel also. This line's a little too long. All right, so now I've canceled everything on the top, so I'm left with 1. And on the bottom, I'm left with the square root of x plus 1 plus 1. Now let's do our direct substitution. So I'm going to plug a 0 in there, and I'm going to get 1 over 0. So that's the square root of 1 plus 1, which is 1 over 1 plus 1, which is 2. Okay, so I'm going to get 1/2 for that answer. All right, the next one, mine was wrong because I had printed it before I posted it for you guys. So let's take a look at this. So the first thing we're going to do is we're going to take a look at E. So if you, quit, if you type E to the first power into your calculator, you get 2.7183 approximately. Okay, well, this limit here, limit as x approaches 0 of 1 plus x to the 1 over x power, I am not going to try to do direct substitution for that. So I'm going to plug that into my calculator. Okay, so I've got it plugged in already for you guys. And then I'm going to graph it for you. Okay, but now let's take a look at the table. Okay, so as we approach 0, let me scroll. Get really close to 0. Almost there. Okay, I'm just going to do it this way. So point, let's go with negative 0.008. All right, so now let's go to our table. Okay, so now I'm getting really close to 0, and you can see as I get really close to 0, as I hit 0, it hits an error. But let's take a look at what's on either side of it. So this one is 2.7196, and this one on the other side is 2.7169. Okay, so what I'm going to have to do here, because they don't actually approach the same number, or they're not showing me the same number, I would have to get very detailed with these. I would have to go, 0.00000 and go really in depth, which I don't want to do. So what I'm going to do here is I'm going to actually approximate the limit. So I'm going to take this 2.7196 plus this 2.7169, and I'm going to find the average of those two numbers. So let's do 2.7196 plus 2.7169, and then divide that by 2, and you'll see that I get 2.7183. So my answer here is actually really close to E. Okay, so in that case, I wanted to approximate the limit using technology. So I could get closer and closer if I change these values. Okay, but really, we don't want to have to just keep going to 0.0000001, right? Because that's going to take forever to do that. So in this case, just approximate if you get close, and then you should get really close to what your answer is going to be here. Okay, let's take a look at the next one. So the next one is sine of x over x. Okay, and on this one, I'm just going to use a graph to do this. So I'm going to go to my y equals. Let's clear out this nasty one we had. So I'm going to do sine of x, and then I'm going to divide that whole thing by x. Make sure that you close this parenthesis here, otherwise it's going to wind up incorrect. And then I'm just going to graph this thing. In a minute. And let's see, I got to be in radians for this. All right, so now let's graph this thing and see if it turns out better. There we go. Okay, so since I'm graphing a sine curve, I need to be in radians, and now I need the sine as x approaches 0 of this graph. Okay, so I'm going to go to my table, and as I get really close to 0, you can see that my y value is 1. Okay, so my answer then is just going to be 1. Okay. And really, if you had plugged this in, it wouldn't work out because sine of 0 is 1, but then your x here would be 0, and that would not work. That would give you that 0 in that denominator. Okay, so that's why you want to make sure that you graph this one to see what it turns out to be. All right, so that is it for 11.2a. Have a great day, and I'll see you next time.